Okay, practice exam 1, there are 20 questions. I will go over non-repeated questions. If questions are repeated, then I'm going to skip that. In the actual test, there will be 15 questions and 90 minutes time. So let's start. First problem, find the average rate of change. I'm going to use completed work so that we can compare our answer. Find the average rate of change of the function over given interval. So this is the function, and there are two problems on interval 4 to 6 and on interval -6 to 6. I'm going to just do the first one. Okay. So average rate of change, to find that average rate of change, to find out the average rate of change, this is the formula we need to use, like f of b minus f of a over b minus a, if we are finding the average rate of change on the interval ab. So in our case, for this particular problem, interval is given 4 to 6. So a is 4, b is 6, the function is 3x cubed plus 3. We need to find out f of b, which is the value of this function at 6 times 6 cubed plus 3. Basically, if you use calculator, you can value, and value of the function 4, 3 times 4 to the power cube plus 3. So we need to plug this value back here in the formula. So if f of 6 means 3 times 6 cube plus 3, I did not use the calculator, I'm just using as it is, because I know that this 3 and this 3 will be cancelled out, so that will be easy for me. So, but you can use calculator and just subtract it, that's okay. 3 times 4 cube minus 3 over b minus a, b is 6, a is 4. This 3 cancel out, and if you do the math here, which is uh, uh, if you use calculator, now I need to use calculator. You can use scientific calculator for this kind of problem, so I'm using calculator for now. So 6 cube um, 4 cube 150 times 3, it's 456 divided by 2, which is 228. So that's the reason the answer is 228. So it's, if you calculate the value on the top and the value on divided by 6 minus 4, that will be 228. So the main thing you need to understand for this kind of problem, the average rate of change, is this formula, f of b minus f of a over b minus a. Okay, that's the first part. You can do the various same thing, second part, skip it. So this is next question, find the slope of the curve at given point p. Find the slope. We need to find the slope here at given point p, and equation of the tangent line at p, equation of the tangent line. So we need both of them. So slope means it's you know slope slope means it's a rate of change. um, okay, once again, let's take one completed work. The answer is already given, but I'm going to explain you how you can get this answer. Okay, so same thing, we're going to here we are going to find out the slope of this curve at this point. So problem 2, you can find the slope by using this formula, by finding this limit h approach to 0. If you want to find out slope of the function f of x, then you need to use this formula. And if you are interested to find the slope at a specific point, then you have to replace that x by that value. In this case, we are looking for slope at point -3. So we are going to replace this x by -3. So we are going to find out this limit. We're going to replace this x by -3. Minus f of -3 over h. So now find out the value of the function. Look at here, the function is y. 4 minus 3x squared. Okay, so you can find the value. Function f of x is 4 minus 3 times x squared. We need to find out the value of the function at negative 3 and negative 3 plus h. So at negative 3, it's 4 minus 3 times negative 3 squared. We do this calculation. Negative 3 times negative 3 is positive 9 times 3 is 27. So 9 times 3 is 27 minus 27 plus 4. So 4 minus 27 is minus 23, right? That's f of negative 3. What about f of negative 3 plus h? Use this function. Wherever you see x, just replace that by negative 3 plus h squared. So if you do that, it will be negative 4 minus 3 and then square it. It will be negative 3 squared, which is 9, negative um, 6h plus h squared. This is basically negative 3 plus h times negative 3 plus h. That will be the value. So distribute this 3. 4 minus 27 minus minus plus 18h minus 3h squared. So if you combine the like terms here, you're going to get negative 20 here as well. So now we're going to know this value in the given formula here for f negative 3h. So I'm going to do that here. This value would be limit when h approaches to 0. The first expression is negative 23 plus 18h minus 3h squared, negative sign, and the value of the function at negative 3 is negative 23. This negative and this negative becomes positive 23. Eventually this 23 and this 23, they will be cancelled out, and we need to find the limit. So before finding the limit, because there is a h on the denominator, we need to find out the way so that we can simplify this. On the top, we can factor out h. By doing that, the leftover thing will be h times 18 minus 3h. On the bottom there is already h, so we can cancel this h. And finally, after this, we can find the limit by plugging h equal to 0 in the second part, and that will give us 18. So that is the answer for the first part, as you can see, and that we can find by using this formula. Okay? For the slope, we always use this formula. Depending on what point we are looking for, we just replace that x by that number. For the second part, we need to find out the equation of tangent line. After finding the slope, the equation of tangent line is this is the formula for equation of tangent line. Equation of the tangent line. Let's say at x1, y1. In this case, x1 is negative 3 and y1 is negative 23, but I'm going to write down the formula first. Y minus y1. M stands for the slope of the tangent line. X minus x1. In our case, slope we found is 18. X1 is given negative 3 and y1 is negative 23. So we're going to plug this value back in this formula. That will help us to find the equation of tangent line. That answer should be this. So let's see here. Y minus y1, which is negative 23. M is 18. X minus x1, which is negative 3. So y plus 23, 18x. You distribute this 18 here. This negative and this negative becomes positive. 18 times 3 is 54. So now we can just simplify by subtracting 23 both sides. That will give us y equal 18x plus 31. That is the answer you can see here. Okay, that's problem 2. Let's go to next problem, and again I'm going to use completed work here, so we already have the answer. We're just going to find out why that answer is right answer, or how we can find the answer. The first thing is find the this is the graph for g of x. Okay, we need to answer this question: what is the limit of this function g of x when x approaches to -4? So -4 is here, as you can see. When x approaches to -4, for finding the limit, keep in mind you need to see from the left direction and then right direction, both sides. From this side, the graph is approaching 0. Again, from this side, the graph is approaching. So when x approaches to -4, left side and right side, the graph is approaching 0. That's why the limit of this function is 0. So let's look at, we try to pick our answer. There are two different options. First one is the limit of the function when x approaches to -4, and this is what we have to fill out. That is 0. Part B, x approaches to -3. -3 is here. Here is -3. X approaches to -3. As you can see that the graph is approaching -4 from the left side and right side. That's why the answer is -4. Let's check the answer. The answer C, x approaches to 0. As you can see that from the left side, graph is approaching to -4. Right side, the graph is approaching +2. That means the left hand limit and right hand limit are not equal. That means the limit does not exist. Part C, we can say that the limit does not exist. See that this is part C, the limit does not exist. For part D, find out the limit of the function when x approaches -0.2. As you can see that -0.2 is somewhere here. And if you try to find out the value of the function on the graph, as you can see that the graph is -4 from the left side and from right side. So that's why answer for the last part is we are looking to solve this limit. We already did one of problem while we found the slope of. We just use a work. We already know the answer. And then we're going to see how we go. Problem question number 4. We have to calculate the value. How we can do this? Question number. So how to find the limit h approaches square root of 6h plus 1 over h. So if we try to find out the limit as it is, then you can see that there is h on the denominator, and that's not going to be helpful. We cannot just plug h equal to 0. So we have to first simplify this expression here. And whenever you see this radical sign, we always try to multiply the numerator and denominator by conjugate of this term. Conjugate means everything same, but the middle sign should be opposite. So I'm going to just multiply the top one by square root of 6h plus 1 plus 1, because I cannot just multiply the top and bottom. I cannot just multiply the top part by something I like. I need to multiply the bottom one by the same thing. Okay, change. Let's see, I'm going to multiply the bottom part by 6h square root of 6h plus 1 plus 1. By doing that, what happens is the top part we are trying to multiply the conjugate terms like a minus b times a plus b. Whenever that is the case, eventually we're going to get 6h plus 1 whole square minus 1 square. Okay, because if you multiply a minus b times a plus b, we don't care what is the value of a. The multiplication would be the difference of a square, a square minus b square. So for this problem, a is square root of 6h plus 1 and b is 1. That's why a square minus b square. On the bottom part, we don't have that kind of thing, so we just keep this as is. Now if we try to simplify on the top part, this would be 6h plus 1 and there is a minus 1. try to simplify further. As you can see that this one and this one, they are opposite sign, they have opposite sign, so you can just cancel them out. On the top there will be 6h and on the bottom there is h. So our ultimate goal is to cancel out this h on the denominator. Okay, so this h and this h cancel out. Now for finding the limit, we can just plug h equal to 0 in the denominator and that will not be any problem here. So if we just find the limit, it will be 6 times 0 plus 1 plus 1, which is eventually square root of 1, which is 1, so 6 over 2, so that is 3. That's why the answer for this question is 3. This problem, how do you find the limit of this kind of problem? Let's use completed work. We already have the answer. I'm going to show you how you can get that answer. The first thing is, if we try to solve this kind of problem, as you see here, uh, just try to plug x equal to -8. Then because this denominator, if you put x equal to -8, it will be 0. It will be undefined thing. So we cannot just plug x equal to -8 for a problem like this. So the idea is try to find the factors on the top and then try to cancel the common factor. So I'm going to show you here 5. If you look at the trinomial have on numerator, we can find the factors of this trinomial. X squared plus 4x minus 32. We need to find out the two numbers product is -32 and whose sum is +8. So think about the factor of -32. 8 times -4. So on the top I can write down x plus 8 and x minus 4. By doing that, this 8 times -4 gives you -32. By adding at a -4, that will give +4. That's how I found the factors. This is just college algebra. And there is x plus 8 on the denominator. I can just cancel x plus 8 from the top and bottom. So now to find the limit, I just need to log x equal -8 here, and that I can do. There is no problem with that. -8, -4, eventually that is -12. That is the answer we have provided. Limit is limit x approach -8 is, after simplification, after plugging the value, final limit is -12. Okay, this is very similar problem like the first problem we I think second problem we did, problem number 2. Exactly the same thing, so I'm going to skip it. I'm going to try, there is an answer, and then you just plug the value of fx h minus f by it. Try to cancel this h on the denominator. You will be able to. Another one, let me use the work. I'm going to do so if the limit is 5, find the limit of the function only. If the limit of this expression is 5 and x approach to 5, the limit of this expression is 5, then find out the limit of the function. So to do this problem, we have to use property of limit. So as you can see that the limit of this expression, so if we can do the first part, the second part is very exactly same, so I'm going to just focus on the first part here. So as we know, we are looking for, this is problem 7. So we are looking for finding the limit of the function f of x when x approaches to 5. This is what we would like to find. The answer is already given here, so I'm going to show you how you can find that answer. So this expression is equal to, when x approaches to 5, I can just divide this f of x by x minus 5 and subtract 7, I can rewrite this thing by multiplying this by x minus 5. Look at here, x minus 5, x minus cancel out. So I'm just subtracting negative 7. And that can be also, balanced by adding 7. So I just rewrite this f of x as, look at here, I just subtracted 7 from f of x and divided by x minus 5. To balance this x minus 5, I just multiply it by x minus 5. Now, still I have negative 7 left over, so I just added 7. So the purpose of doing this is now I can apply the limit laws. So I can, if I have this thing inside the bracket, because we know that the limit of this expression exists, the limit of this thing exists, which is 5. The limit of x minus 5 when x approaches to 5 is also finite value, which is 0. And then limit of 7 when x approaches to 5 also a finite number. So we can apply the property of the limit now, and we can write it down like limit x approaches to 5 of the first expression, which is f of x minus 7 over x minus 5 times limit of x minus 5 when x approaches to 5, the limit of the first expression times the limit of second expression, and it's coming from property of the limit. So I'm not doing anything which is not, which is not allowed or which is not from the property. So now, because the limit of this expression is 5, as you can see here, 5, so this goes to 5, but the limit of this expression would be 0. So 0 times 5 is 0. For the first part, the limit is 0. And now second part, the limit of the function 7, which is constant function, when x approaches to 5 is 7 itself. So that's the reason the answer for the first part is 7. Okay, and answer for the second part, you can exactly do the same thing and you are going to get the same answer. Okay, find out the delta for this given problem here. So as you can see that the graph of the function is given, and we have given the function f of x, which is 4x minus 5. We have given the limit of the function. We have given the constant c. We have given epsilon. For this epsilon, we need to find out the delta. So I'm going to use, this is problem 8. So whenever you need to do this kind of problem, you always start with f of x minus L minus absolute value of this thing is less than epsilon. Always start with this and try to find a way, try to simplify this such that you are going to end up with x minus c is less than some number. That number will be the delta. So I'm going to start with this and I'm going to play with that f of x minus L to make it x minus c. Okay, so let's go here, plug the value of f of x. In this case, it's a 4x minus 5. L is 15. Epsilon is 1.6. Okay, so now if I simplify, remember I need x minus c. X minus c, c is 5. So how do I go from here to x minus c? 4x minus 20, that's the simplification. And if I factor out 4, absolute value of 4, it's going to give me x minus 5. Absolute value of 4 is itself 4, so I can just divide both sides by 4 and still my inequality holds. By doing that, I'm going to get x minus 5 is less than, what is this, 0.4. So I started with f of x minus L is less than epsilon, and I end up with this x minus c is less than some number. And that number is 0.4. That means the delta should be 0.4. That's why if we check the answer here, the delta is 0.4. Okay, this is another problem where we are going to use epsilon delta idea here. So to solve this problem, this is the word problem here. As you can see, before contracting to grind engine cylinders to a cross-sectional area of 9 inch square, you need to know how much deviation from the ideal cylinder diameter of C equal 3.385 inch you can allow, and still have the area come with 0.01 inch square of the required 9 inches square. Find out, let the area can be found by using this formula pi x over 2 square, and look for the interval in which you must hold x to make this value. What interval do you find? So first of all, this is problem 9. Make sure that we're talking about cylinder here, and then the cross-section area of the cylinder, and remember the cross-section area of the cylinder A equal pi r square. That's the formula. In our case, we want a cylinder. So we have given the cylindrical diameter C equal 3.385, and we want the area. The area should be 9 inches square, but you can have slightly less or slightly more. Slightly means in this case it's a 0.01. So we could construct this area, you know 0.01 less than 9 to 0.01 more than 9. So could be area could be 0.01 less than 9 is, it's a 8.99 to 10.01. So area could be 8.99 to 10.01. That's okay. But we need to find out what is the value of x. Here x means it's actually, it's a diameter. X is diameter. That's why diameter divided by 2 is radius. So the cross section area would be pi r square. So we need to find out the range of x such that area might be anything in between 8.99 to 10.01. So this is actually the very same problem we did before. It's epsilon delta problem. So we start with the given condition here, a minus 9 is less or equal to 0.01, and eventually we want x minus c is less or equal to something. Eventually we want the value of x, the range of x. So you start with this one, absolute value of a minus 9 is less or equal to 0.01. You can rewrite this as a 0.01 less or equal to a minus 9 is less or equal to 0.0. As you can see, that's what I did here. And I already found s would be in between 8.99 10.01. I can get that by adding 9 here in this inequality. If I add 9, oh, so it's not 10, so sorry about that. So just did minor mistake here. It should be 9.1 because I'm adding 0.01 to 9, so that's how I got this 9 point. So let's go down here, and by doing that on the left side I'm going to get 8.99, area 9.01. area should be in between this. For this, what should be the range of x? That is what we would like to find out. But we know a is pi x squared divided by 4. If you remember, the formula we have given here is a equal pi times x squared over 4, less or equal to 9.0. Just try to find out the x by simplifying this thing. So I'm going to multiply everything by 4. By doing that, this 4 and this 4 cancel out. After that, I'm going to divide it by pi. Remember, this is times. And after that, I need to find out the x, so I'm going to take the square root of these numbers. Still the inequality holds because they are positive number. So if I do that, square root of 4 times 8.99 over pi, square root of 9.01 times 4 over pi. So the range of x should be this. But while we try to put the answer here, make sure that we read this instruction. Type your answer in the interval notation. Round the left in point, that means this one. Round the left in point up. So let me just use a calculator here. Let's say scientific calculator. And on the left side, oh, where is that? Okay, here. On the left side, we have 4 times 8.99 divided by pi. 4 times 8.99, 4 times 8.99 divided by pi, and take the square root of that. Take the square root of that answer. If I do that, the answer is 3.38325. But read the instruction here. Type your answer in the interval notation. Round the left in point up. So here, as you can see, that the answer should be 3.383, but we're making it 1 point up, so it's 3.384. That's the reason the answer here is 3.384. Okay, and when you put right in point, we go one step down. We're trying to take nearest thousand, so that's the reason after decimal there are 3 digits. Okay, so to calculate the right in point, you just have to multiply 9.01 by 4 divided by pi and take the square root. So I'm going to use that scientific calculator one more time. 9.01 times 4 divided by pi, take the square root of that. That is 3.387, but one step down, so it will be 3.386. So if you go here and check the answer, right in point down to the nearest thousand as needed. Okay, sorry, it's a nearest thousand. So when you look at here, 3.3870, so the downer 701, so we're going one step down, so it will be 3.87, 0.387. Okay, we're not going up. 701, if you go down, it would be 700 only. That's why it's a 3.387. The answer here is 0.387. Okay, that's how we find answer by using this epsilon delta concept we used before. Okay, let's go to next problem. Couple of extra pages here so that pages next time. Okay, let's go to next problem. This is the graph. We need to find out the this answer. Could use the completed work here, and I'm going to this is the graph, and first one, find the limit of the function when x approaches to 2 from right side. Here, x approaches to right side. This is the graph. X approaches to 2. 2 means 1 and 2 here. From the right side means this side. This is the graph you have to use. X approaches to the right side. This is the graph is approaching to 1, 2, 3. The answer for that one is 3. Right hand limit. Answer for that one is okay. That's the reason the answer for when x approaches to 2 from right side, the answer is 3. When x approaches to 2 from the left side, as you can see that from the right side it's 3, from the left side it's 1. That's the reason it's 1. From the right side it's 3, and from the left side, it's 1. So let's go to the part B. Does limit of the function when x approaches to 2 exist? So look at the graph here. When x approaches to 2, 1, 2, As you can see that the left hand limit and right hand limit, they are not equal, so the limit does not exist. So no, limit of the function does not exist because the left hand limit and right hand limit from this, they are not equal. For part C, find the right hand limit and left hand limit when x approaches to 3. So 3 is here, as you can see. 3 is here. 1, 2, 3. When x approaches to 3 from the left hand and right hand, to find out the exact value, we can use this function x plus 3. When x approaches to 3, the value is 4, either from the left side and right side. Same thing. So the limit is 4. And because of that, the left hand limit and right hand limit, they are equal. The limit does exist and then equal to 4. Problem 10. How to find this limit? This is exactly same idea as one of the problem we did before. I think it's problem B, I guess. No, problem 4. This is problem 4. So here is the square root. To simplify the square root, we multiplied numerator and denominator by conjugate. We're going to do the exactly same thing here. Multiply this problem, the top part and bottom part, by its conjugate. So square root of h square plus 6h plus 17 plus square root of 17 on the top and bottom. Simplify the way we simplify in problem 4. Eventually you are going to get this limit. Skip it for you. Okay, for this problem we have to use the limit of sine theta over theta is equal to 1. Remember, this theta, you can replace it by any other expression. So I'm going to just use completed work here. So what is the limit of this thing? I'm going to show the work for here for this particular problem. Okay, this is problem 12. Problem 12. So look at here. Whenever you look at the problem, we need to find out the limit of 4 times sine square root of 9 times theta over square root of 9 times theta. So think about this. This square root of 9 times theta is actually, you can simplify this. Square root of 9 is actually 3 theta. So this is eventually sine 3 theta over 3 theta. So one thing you have to keep in mind, if we know that the limit of sine theta over theta equal 1 if that theta approaches to 0. So we can replace this theta by anything. Limit of sine of anything over that anything, when that anything approaches to 0, is always 1. So here in this problem, when theta approaches to 0, 3 theta approaches to 0. So instead of saying, okay, limit theta approaches to 0, 4 times sine 3 theta over 3 theta, instead of saying that, we can also say, oh yeah, this is actually limit 3 theta approaches to 0, 4 times sine 3 theta over 3 theta, right? When theta approaches to 0, 3 times theta is also approach to 0. So now we can use the property of the limit. We can find the limit of 4, which is constant function, or we can keep that constant outside, and we can just find out the limit of this expression, sine 3 theta over 3. This is actually 1. It's a 4 times 1 is 4. That's the reason the answer for this problem is 4. Okay, find out the value of the function at 2. So look at the graph. What happens at 2? At 2, the value of the function, there is a circle. So for what value of the function at 2, this graph would be continuous? What value should be assigned to f of 2 to make the extended function continuous? So we know that to be a continuous function, the value of the function at any point and the limit of the function at that point should be equal. So in this case, focus here, the limit of the function when x approaches to 2 is 2. And the value of the function at when x equal to 2 is, it's also 2. So no, x equal to 2, and that is not defined here. When x equal to 2, if the value of the function is 2, then the graph is continuous. So we can say that, let me just choose see the completed work. In this case, the graph is different now. So let's go back here one more time. 2 at 2, the limit is 1. So if the value of the function is also 1, then the graph would be continuous. So when we answer, if the value of the function is 1, this would be equal to the limit of the function 2. That's why it would be continuous. If you remember, to be continuous function, these are the three things you need to satisfy. This is problem 13. A function f of x is said to be continuous at x equal to a if the limit of the function x approach to a is equal to the value of the function at value, and the limit should be equal. We are going to use this, we use this approach, this definition, to find out this answer. The limit of the function at 2 is 1, value of the function at 2 is also should be 1 to be continuous. Okay, at what point is the following function continuous? We For this kind of problem, if we are dealing with piecewise function, we know that this is you know rational function. This is just a rational function, and this function is continuous everywhere wherever this function is defined. These are the constant values, so they are also continuous. So the only problem we have to look at is at the boundary point. What happens when x is -3 and +3? Is this function still continuous? Let me just use the completed work. It will give me very similar question here. I'm going to use this question to answer the question, to answer this the question we have given. So this is problem 14. Function is f of x is when x is not equal to 4 or -4. Simplify on the top, that will be x minus 4 times x squared plus 8 at 4x plus 16. So as you can see that on the top, there is x cubed minus 64, which can be written as x cubed minus 64 can be written as x cubed minus 4 cubed, which is basically x minus 4 x squared plus 4x plus 16. You just distribute this, you are going to get x cubed minus 4 cubed. Okay, so on the top, these are the factors. On the bottom, as you can see that x squared minus 16 means x minus 4 and x plus 4. Cancel this, right? So now this is the most simplified form. So as you can see that when x approaches to negative, when x approaches to +4, there will be no problem here. When x approaches to +4, we can find out the limit, which is 4 squared plus 16 plus 16, which is, we can find out the limit. That limit should be the value of the function. So when x approaches to 4, add some here. So we can write down this function one more time. The function is x squared plus 4x plus 16. That's we got by canceling the common factor x minus 4 and x minus 4. Remember, if you multiply x times x squared, it will give you x cubed. If you multiply 4 times 16, it will give you 64, and in the middle term, it will be cancelled out. Okay, that's why on the top it will be x squared plus 4x plus 16. On the bottom it's x plus 4. You cannot further find the factor of this. You try to find the limit of this function when x approaches to +4. That's just the value of this function at +4. So just plug x equal to 4 here. So 16 plus 4 times 4, 16 plus 16, 4 plus 4, which is 48 divided by 8, which is 6. That's the limit of the function when x approaches to +4. That is the value of the function when x is equal to, that's given here. So this function is continuous at 4. But for the negative 4, you cannot find the limit here. When x approaches to negative 4, you try to find the limit here, it will be undefined. But the value of the function is 4. But that is not the case. That's why the limit of the function and then the value of the function, they are not same. That's why this function is not continuous at negative 4. So the function is continuous everywhere else except at negative 4. The very same idea, we have given a function x squared minus 7 if x is less than 4, and 2 times a times x when x is greater or equal to 4. We want to find out for what value of a the function would be continuous. We're going to use the same idea, the limit of the function at 4 and then value of the function at 4. If that is equal, that will be continuous. This is question 15. Limit of the function when x approaches to 4 and then value of the function at 4, that should be equal. Why I choose 4? Because it is the only problem, the only place, where we can use both of them. Because if you try to find out the limit, you can use the left hand side, and if you try to find the value, you can use the right hand side. If limit exists, then left hand limit should be equal to the limit of the function. Okay, and the value of the function can be found by using the right side. So now here the limit of the function x approaches to 4, if limit exists, if this function is continuous, then limit should exist. If limit exists, then the limit from the left hand side should be equal to the limit of the function, and value of the function at 4 only can be found by the right side, so it would be 2 times a times 4. So if you try to find out the limit of the function from the left hand side, you have to use the top part, which is x squared minus 7. This is 8a. So this is 4 square, which is 16 minus 7 is 16 minus 7 is 9. So that's why a equal 9 over 8. If you choose a equal 9 over 8, that makes this function continuous. Oh, I forgot to use the completed. So, by doing the same thing, you can find out a equals 7 over 6. And this is different answer because this is different question. Here I was doing, x squared minus 7, but here you have given x squared 2. So, and then limit is at 3. So if you use the very same idea, it will be 7 over 6. Same problem. So I'm going to skip it. Same problem. Limit from the left side, limit from the right side should be equal to be a continuous function. And the limit from the left side is 24, and the value of the function at 3 is, you can find by using this function, which is a squared times 3 plus 6 times a, and now you have to solve quadratic equation. Okay, I'm going to skip it. So next problem, find out the limit when x approaches to positive infinity and negative infinity. So we have given 1 over x. 1 over x is the function we have given on the denominator. As we know that 1 over x, this is 1 over x. When x approaches to positive infinity, this graph approaches to 0. When x approaches to negative infinity, again this graph approaches to 0. So when we try to find the limit, the denominator part, this part would be 0. Let me just use a completed part. This part would be 0. 18 over 19 is your answer. Same thing is true. Whenever x approaches to negative infinity, 1 over x approaches to 0. 18 over 19 plus 0. This 0 would not be a problem. Just plugging the value by looking here, this graph. When x approaches to infinity, 1 over x approaches to 0. When x approaches to negative infinity, again 1 over x approaches to 0. Okay, so let's answer a couple of questions here. Find the horizontal asymptote and vertical asymptote. For this question, let's complete it. For this question, the horizontal asymptote, we just have to compare the degree on the top and degree on the bottom. If the degree on the bottom is greater than degree on the top, the horizontal asymptote would be always y equal to 0. As you can see that in this problem, which is problem 18, the degree on the top is just 0. The degree, there is no degree, there is a constant term, and the degree on the bottom is 1. So when x approaches to positive infinity or negative infinity, it approaches to 0. So that's the reason y equal to 0 is a horizontal line. That's the answer. For the vertical asymptote, just take the the denominator part and equate this to 0. Solve for x. That will give us the vertical asymptote. X equal to 6 is the vertical asymptote. Now, to choose the correct graph, we're going to choose the graph where y equal to 0 is the horizontal asymptote and x equal to 6 is vertical asymptote. Get here x equal to 6. Look at the first one. Oh, here x equal 6 is vertical asymptote. But when x approaches to positive infinity, this graph approaches to 0 from up. But when x approaches to negative infinity, this graph approaches to 0 from the down, not be the up. And you can verify that thing by finding the value of the function at x equal to 0. When x is 0, the value of the function should be negative, but it's positive. So this is not the right graph. Similarly here, you can see that 10, this is 10, then should be 5. That's not the right vertical asymptote. If you look at this one, which is the right answer, x equal to 6, the vertical asymptote, y equal to 0 is horizontal asymptote. This graph is up, positive. This graph is down, negative. That's why this is the answer. Find the limit when x approaches to negative infinity. What is the limit? X approaches to negative infinity. The hint is given. Try multiply and divide by the conjugate. So this is very similar problem like we did before here, dividing and multiplying by the conjugates. So we can do the same thing here for this particular problem. Just add two more pages. So for this problem, let me use the completed work. And for this problem, if we multiply this by conjugate, x plus, this is problem 19, I guess. 19. X plus the square root of x squared plus 7x minus 9. If I multiply this thing by its conjugate means same terms but different sign. I multiply this by conjugate, which is x minus square root of x squared plus 7x minus 9. I also have to multiply the denominator by the same thing. If we do this on the top, we're going to see the top, it will be x squared minus the square of this radical sign, so it will be without radical sign. But on the bottom, we still have radical, x squared plus 7x minus 9. So on the top, we can just simplify x squared minus 7x plus 9 over x minus square root of x squared plus 7x plus 9. So this x squared cancel out, and on the top we will have negative 7x plus 9, and on the bottom we will have x minus square root of x squared plus 7x minus 9. So if we try to find out the limit of this expression when x approaches to negative infinity, you can find by comparing, because the degree on the top is 1 and the degree on the bottom is also 1. So you can simplify this. For simplification, you can just divide the top one and bottom one by x. Okay, so limit. So what I can do is I can just factor out x from the top one. It will give me negative 7 plus 9 over x. On the bottom one, I can do the same thing, x will give me 1 minus, so square root of x square x, this is actually square root of x square. Okay, that will be 1 plus 7 over x minus 9 over x. Okay, so look at here. When x approaches to infinity, this part goes to 0, this part goes to 0, this part goes to 0. And what happens to this? What is that? What happens to this? Okay, what I did here, okay, so what I did is, uh, when x approaches to, the one thing you have to keep in mind here, uh, let me give you some explanation. When x approaches to negative infinity, this square root of x square is, actually negative x. Okay, so because when x approaches to negative side, negative value, the square root of x square might have positive x and negative x, two situations. So the relation is, when x, if you try to find out the square root of x square, it will be negative x if x is negative, and it will be positive x if x is positive. So think about this. You want to find out the square root of 4 square, then that will be 4. But if you want to find out the square root of negative 4 square, that will be negative times negative 4, which is eventually positive 4. So square root of x square is negative x if x is negative itself. And don't be confused. The value of x is negative. It does not mean that the the value of x should be negative. But this negative is different than the value of x itself. So whatever value you put here, that will be eventually be positive because of this negative sign. So this is the definition we need to use to simplify the expression here. So when we try to simplify here, we can factor out square root of x square. I can write down this x as negative of square root of x square. By doing that, this negative of square root of x square is x. Why we can do that? Because we are just interested to find what happens when x is negative. So when I simplify this negative square root of x square, okay, it will be 1 plus square root of 1 plus 7 over x minus 9 over x. By doing that, what happens is, when x goes to infinity, this goes to 0, this goes to 0. Now look at here. This negative x is actually square root of x square. And there is a negative x square. So this will be cancelled out. Now if you try to use that limit, when limit x goes to infinity, on the top and bottom, you should be able to cancel this one. And this one would be 0, this one would be 0, this one would be 0. So eventually negative 7 on the top and 1 plus square root of 1, which is negative 7. And then did I miss something here? Negative 7 on the top and then 2 on the bottom. What did I miss? I think I miss the negative sign here. Negative square root of x square. No, it's just a square root of x square, not the negative. Because x is a square root of x square. Now it will be fine. Okay, so when we try to do this kind of problem where there is a square root and there is an even power inside the square root, if you are looking for this x approach to negative infinity, you have to use this relation. Square root of x square is negative x if x is negative 0, if x is less than 0, and square root of x squared is x itself if x is positive. Okay, so there are two different kind of question here in this particular problem. One is find the average speed, another one is find the instantaneous speed. Average speed means, for example, let's say at 0 to 1, 0 to 1, just focus on 0 to 1, 0 to 1. Average means find the value of the function at 1, which is uh, 10, at 0, which is 0. So 10 minus 0 is 10, divided by, the the difference on that interval, which is 1 minus 0. So it's 10. That's the reason the answer is 10 miles per hour. Because to find out the average speed, you just have to find out the average value on that interval by using the formula f of b minus f of a. The first formula we write, f of b minus f of a over b minus a. You have to use the same formula for finding the average speed. And now you can do the same thing for rest of the problem. Now here, for b, you need to find out the instantaneous speed. Instantaneous means it's the slope of the tangent line at that point. So in this case, it says what is the slope of the tangent line when t is half. So focus, zoom in your graph. T is half means here. When you try to find out the slope of this tangent line, as you can see that this is the tangent line, you have to approximate it. You have to use the approximation. You can just draw a line here, and you have to look at the possible options you have. So there are negative value and two positive value, 10 and 60. So we just have two possible answer because the average, the rate of change, if you try to find out the slope of this line, this is positive. And now the slope means it's a rise over run. So as you can see that the rise is, if I draw a line here, the rise is 4 divided by it's a 0.5, more than 0.5, more than 0.5, so it should be 0.6. 4 divided by 0.6. So if you divide 4 by 0.6, eventually 4 divided by 0.6, that's just approximation value, or maybe it's 0.7, I don't know. So just focus on the graph we have given. It's, if you try to draw a line through a half, this is half. The one point you take from here and another point you take from here, so that is from here to here it's 4. 4 divided by, it's 0.3.5, 0.5. 4 divided by 0.5 is 4 divided by half, which is 8. So it should be approximately 8, but that answer is not available we have here. What is that? The closest answer is 10. The reason for this is, we don't know exactly, when we try to draw a tangent line here, we don't know exactly, the difference, the value. So we have to approximate. For the approximation, you find one answer and you try to see which one is the closest value to your answer. Okay, you can do the same thing for the rest of the problem.